This is Math 10-3, Lesson 4.2. We're going to look at mass in the Systeme Internationale, or the SI system, or the metric system. So, in the metric system, our basic unit of measure is in kilograms. Okay, so kilograms. And often mass is mistaken for weight, right? We talked about pounds being the weight, and kilograms is mass, so it's a measure of how much stuff is there. I know that on Earth we can relate them because they have a pretty constant acceleration of force of gravity acting on them, but to keep it straight in our head. On this metric chart, our kilograms sits here. And as I'm converting to smaller units, I move down, so I'd be going down this way. And if I'm going down this way, I multiply. And each box I move is a multiple of 10. So if I go from kilograms to grams, I'm going 10, 100, 1,000 that I would multiply from. So there are 1,000 grams in 1 kilogram. And you'll notice that that is right here as well. 1,000 kilograms in 1,000 grams in 1 kilogram. If we continue on down, we can move from grams to milligrams, and there are 1,000 milligrams in 1 gram. Now there's another unit conversion right here that's important, our conversion factor, and that is 1,000 kilograms equaling 1 ton. And it's important because we'll use it. It doesn't fit on that lovely chart where as you move up and down, you're moving decimal points. And so we'll have to use that as a factor, a conversion factor. The other important pieces that are on your formula sheet are the relationships between pounds and kilograms. And the most commonly used one is 2.2 pounds for 1 kilogram. Sometimes you'll use that 1 pound is equal to 0.45 kilograms, but that's not as common. And there is a relationship between ounces and grams. 1 ounce is 28.3 grams. And here, notice this one's is kind of important because what we have is tons and tones. This metric tone, T-O-N-N-E, is the unit on it is just T, and so that's a metric ton. Sometimes it's said a metric ton. And the other ton, that's a 2,000 pounds, is T-N, and so your conversion factors sit right here on your formula sheet. Let's do some examples now. A recipe for cornbread calls for 120 grams of flour, 170 grams of cornmeal, and 50 grams of sugar. If you double the recipe, what is the total mass of the dry ingredients? There's a couple of ways that we could do this. We could take the 120 and double it, and we could take the 170 and double it, and we could take the 50 and double it, and then add them together. Or we can add them together and then double it. And that works because we're looking for the total mass of the dry ingredients. So let's add them together. So 20 and 70 is 90, and 50 is 140. Carry that 100, so we have 340 grams. Now we're going to take those 340 grams and double that recipe, and that gives us 680 grams of total mass in our of dry ingredients in our doubled recipe. Let's go on to our next example. Lorinda is baking apple pies. According to her recipe, she needs 6 pounds of apples. The apples that she bought only show their mass in kilograms. How many kilograms of apples does she need? Well, if we go to our formula sheet, I can just go back there. We can see, oh yeah, this is the more commonly used one. 2.2 pounds is equal to 1 kilogram. Let's take that here. So we know that 2.2 pounds is equal to 1 kilogram. And we can write that in our, as a ratio, 1 kilogram for 2.2 pounds. We know that we have 6 pounds, and we want to know how many kilograms that is. So we take 6 times 1 divided by 2.2, and that's going to tell us how many kilograms we have, and it is 2.7 kilograms. So Lorinda needs 2.7 kilograms of apples. Let's look at example number 3. The cost of bananas is 0.49, so 49 cents a pound at one store, but you've seen an advertisement for bananas on sale at another store for $1.05 per kilogram. Which one's the better buy? We know that for 49 cents is the cost for 1 pound of bananas, and that 1 pound of bananas has a mass of 0.45 kilograms. So we can simply replace the 1 pound with what it's equal to. Then we take that 0.49 and divide it by the part of a kilogram it is, and we find that it's 1.09 cents per kilogram. That's what we would get if we convert it to kilograms from the pounds. Let's do the other way, where we have 100 or $1.5 per kilogram, and we know that a kilogram is 2.2 pounds. And so we can divide that out, 1.05 divided by 2.2, and this comes up to 0.48 cents for 1 pound. Either way, we can see, oh yeah, that's cheaper slightly than the cost given in pounds, dollars per pound, and we can see that the dollars per pound is a little more expensive. You're going to want to practice these skills, so take a moment, pause the video, record this. I've just tried a different order here. You can see if that works for you, and I will get onto a new video for you for Friday. Have a good day.